Everybody thinks solar storage begins with a battery. That's the first mistake. They think if you want to capture sunlight during the day and use it later, you need a wall full of lithium, an inverter upgrade, a permit stack, an electrician, a financing package, and a sales rep explaining why the real savings don't begin until year 9. But sunlight does not care about financing. Sunlight does not need a subscription. And the cheapest way to store solar energy was hiding in plain sight before home batteries became fashionable. Water. That's the secret. Not a rare mineral, not a smart app, not a backup pack the size of a refrigerator. Just water, a dark container, and a little insulation. That's the $3 setup. And before you laugh, understand what I'm saying. This does not store solar electricity the way a lithium battery stores electricity. It stores solar energy as heat. And for huge parts of real life, that is exactly what people need. Hot water, warm air, reduced evening energy demand, lower utility dependence, less wasted solar, and it works because thermal storage is not a fringe hack. The US Department of Energy explicitly says energy can be stored in different forms, including thermal storage, and that fluids, such as water, can be used to store heat in insulated tanks until the energy is needed. That changes the whole conversation, because the average homeowner has been trained to think in only one language: electricity in, electricity out. Solar panel makes power, battery stores power, house uses power. Clean, simple, expensive. But the Department of Energy flat out explains that storage is broader than batteries. Energy can be captured and stored as chemical, thermal, or mechanical energy, then released later when needed. That means if your goal is to shift part of your daytime solar gain into the evening, you don't always need electrochemistry. Sometimes you just need a material that holds heat well and gives it back slowly. And this is where the $3 idea starts humiliating more expensive systems, because water is freakishly good at holding heat. The US Geological Survey explains that water has a high specific heat, which means it takes a lot of energy to raise its temperature compared with many other substances. USGS even quantifies it. Water absorbs 4,184 joules to raise 1 kilogram by Warner Gericks. In plain English, water can soak up a lot of heat before changing temperature dramatically, and once it gets warm, it doesn't throw that heat away as fast as a lot of other materials. That is exactly why water is used in cooling systems, why oceans regulate climate, and why a sun-heated bucket of water behaves very differently from a sun-heated piece of metal. So now think about what that means for solar. If you put sunlight into water during the day, and you prevent that heat from escaping too quickly, you have created a thermal battery without buying a battery. That's not internet magic, that's just physics. And the funny part is that official energy agencies have been describing versions of this for years. The Department of Energy says solar water heating systems include solar collectors and storage tanks, and calls solar water heaters a cost-effective way to generate hot water for homes. DOE also notes they can be used in any climate, and the fuel they use, sunshine, is free. Read that carefully. Collector, storage tank, free sunshine. That is the whole scam being exposed. The expensive myth says storage must begin with a battery cabinet. The older, quieter truth says storage can begin with a tank. And that truth gets even better when you look at Energy Star's explanation of solar water heaters. It says solar water heaters come in different designs, but they all include a collector and a storage tank, and all use the sun's thermal energy to heat water. Energy Star even describes batch collectors, also called integrated collector storage systems, that heat water in dark tanks or tubes within an insulated box, storing that hot water until it's used. That's basically the forbidden version of the idea right there. A dark container, an insulated enclosure, sunlight, stored heat. Now, do you see why the $3 version scares people? Because once you understand the principle, you stop worshiping complexity. You realize there are two different games being played. Game one is electrical storage. That's for running appliances, backup circuits, electronics, and nighttime loads that demand electrical output. Game two is thermal storage. That's for storing heat itself, for water heating, preheating, passive warming, greenhouse stabilization, or reducing the amount of grid energy or gas you need later. And if you're honest, an enormous amount of household energy consumption is basically thermal, heating water, heating air, offsetting heat loss, managing comfort. So if sunlight can be captured as heat and parked in water until later, that means you are storing useful solar energy without touching a lithium cell. That's the hidden punchline. This won't run your gaming PC all night, but it can reduce how much energy you need to buy to do heat-related work, and heat-related work is a giant slice of utility bills. The Department of Energy says thermal energy storage uses a fluid, such as water or molten salt or another material, to store heat in an insulated tank until the energy is needed. DOE also says the stored heat may be used directly for heating and cooling, or in larger systems can even be used to help generate electricity. That means the principle is not a toy. It scales all the way from home hot water logic to grid-scale energy strategy. So what is the $3 setup in practical terms? At its core, it is embarrassingly simple. A dark water container placed where it can absorb sunlight, combined with enough enclosure or insulation to slow heat loss. In the most primitive form, that can be a cheap dark jug, black painted container, or thrift store vessel used as a non-potable thermal mass experiment. In a more serious form, it becomes an actual solar water heating or thermal storage setup with proper collectors, plumbing, and safety controls. Same principle, different level of engineering. And that's the part that should make people uncomfortable, because the physics does not suddenly become valid only when an expensive company packages it. The expensive version is not more real. It is just more engineered, more efficient, and more convenient. The cheap version still works at the principal level. Sun hits dark surface. Heat enters water. Water stores heat because of its high specific heat. Insulation slows losses. Later, that stored heat offsets another energy demand. That's it. No chemistry pack, no rare earths, no cycle degradation charts, no thermal runaway headlines, just stored sunlight in the form of heat. And yes, utilities and energy companies have reasons not to get excited when people understand this, not because they're sitting in a bunker terrified of black buckets, but because customer ignorance is profitable. If people believe storage only means expensive batteries, then they never notice how many smaller, smarter, lower-cost thermal loads can be shifted with almost laughably simple methods. Once that mental lock breaks, everything changes. You start looking around your home differently. You stop asking, how do I store electricity for everything? And you start asking, which of my biggest energy needs are really just heat? That question is deadly because hot water is heat. Shower energy is heat. Dishwashing energy is heat. Part of space heating is heat. Greenhouse overnight moderation is heat. Radiant storage is heat. And heat is where water becomes a monster. USGS explains that water takes a lot of energy to warm up and also changes temperature more gradually than many materials. That slow, stubborn thermal behavior is why water works as a stabilizer. It absorbs excess heat when available and then gives it back over time rather than dumping it instantly. That is exactly what you want from storage, not flashiness. Stability. The same federal sources also make clear that passive solar and passive solar water heating ideas are not fringe nonsense. DOE says there are active solar water heating systems with pumps and controls, but also passive systems that don't. Energy Star says passive systems can rely on natural convection rather than pumps to move heat. So even the official language is telling you something radical. Not every solar storage concept needs electronics, controllers, or battery chemistry to function. But now let's destroy the biggest lie before it causes confusion. This is not a universal substitute for batteries. If you hear stores solar power without batteries and imagine running an air fryer, a TV, and a freezer all night from a hot bucket, stop right there. That's not what this is. This is thermal storage, not a full replacement for electrical storage. It is best when your use case is hot water, space heating assistance, or any system where stored heat is directly useful. The DOE explicitly distinguishes thermal storage from electrochemical batteries and mechanical storage because they serve different roles, and there are real cautions. Energy Star notes that batch collectors can make water very hot and that tempering valves may be needed to prevent scalding. It also says certain systems are not recommended in cold climates or require freeze protection. DOE similarly notes that solar water heating systems vary by climate and design. So the cheap idea is real, but the serious version still needs common sense and code-compliant design if you're turning it into household infrastructure. Still, the principle is devastatingly simple. If the sun gives you more heat during the day than you need immediately, and if water can absorb and hold that heat, then you can move useful solar energy into later hours without buying a battery. That's why this feels like cheating, because in a way it is. It cheats the modern assumption that every energy problem must be solved with a high-tech product stack. The Department of Energy even goes one level deeper and describes a kind of virtual storage, where buildings or water heaters can be heated or cooled ahead of peak demand so they don't need as much energy later. DOE literally says a similar process can be applied to water heaters to spread demand out over the day. Think about how crazy that is. One of the most boring appliances in your house can act like storage. That's the real fear here, not the $3 container itself. The idea that storage can be cheap, local, understandable, and partially built from common materials. The idea that sunlight captured at noon can reduce purchased energy at 7 p.m. without passing through lithium first. The idea that people might stop confusing storage with battery and start seeing thermal mass, hot water tanks, and passive solar collectors as tools instead of relics. That is a dangerous idea if your business depends on people only seeing the expensive path. So if you want the clean version of the truth, here it is. The $3 setup is not some magical perpetual machine. It is a humble thermal storage principle. A dark container plus water plus sunlight plus insulation equals stored heat. Scale that up, engineer it properly, and you get solar water heaters, storage tanks, and passive thermal systems the government and efficiency programs openly describe. Scale it down, and you still get the same physics. Cheap solar storage, no batteries, no moving parts, if you stay passive, no mechanic, no app, no recurring bill from physics. That is why this topic matters. Because once you understand that energy storage can be thermal, not just electrical, you stop being intellectually trapped by the most expensive version of the problem. You start designing around need instead of hype. Need hot water later? Store heat. Need overnight greenhouse stability? Store heat. Need to shave evening heating demand? Store heat. Need to reduce what the grid sells you after sunset? Store heat. And water will do the work all day if you let it. So no. The secret is not that a $3 gadget can power your entire house overnight. The secret is smarter than that. The secret is that sunlight stored as heat and water is real energy storage, officially recognized, physically powerful, and shockingly cheap at the principal level. The Department of Energy says solar water heating systems use collectors and storage tanks. DOE says thermal storage can use fluids like water in insulated tanks. USGS says water has a high specific heat, meaning it stores heat unusually well. Energy Star says even simple solar water heating designs use dark tanks or tubes and storage principles to hold that solar heat until later. And once you realize that, you start asking a very dangerous question. If the cheapest solar storage in the world was sitting in the plumbing aisle all along, how many expensive solutions were really just overpriced ways of making you forget what water can do?